Astronomers have been able to hear the celestial hum of powerful gravitational waves, created by collisions between black holes, echoing across the universe for the first time. Their observations reveal that the waves, including some that slowly undulate as they pass through our Milky Way galaxy, occur at different frequencies and oscillate for decades. The discovery could help scientists better understand cosmic phenomena like supermassive black holes and how often galaxies merge. Gravitational waves, initially predicted by Albert Einstein in 1916, are ripples in spacetime that were first detected in 2015. Astronomers found the waves by tracking pulsars, or the dense remnants of cores belonging to massive stars after they explode in a supernova, across the Milky Way. Pulsars are like stellar lighthouses, rapidly spinning and releasing beams of radio waves that seem to pulse when viewed through Earth-based telescopes. Pulsars can spin hundreds of times each second, and the stable precision of the pulses makes them as reliable as cosmic clocks. When gravitational waves pass between Earth and a pulsar, the radio wave timing of the pulsar is disrupted. Einstein theorized that gravitational waves would stretch and compress space as they moved across the universe, affecting how radio waves travel. This means some of the pulses reach Earth a fraction of a second earlier or later than expected. More than 190 scientists set out to discover the frequencies of gravitational waves as part of the North American Nanohertz Observatory for Gravitational Waves Collaboration, also known as NNOGrav. They tracked the radio waves from more than 60 pulsars for 15 years using 3 large radio telescopes, the Arecibo Observatory in Puerto Rico, which is no longer operational, the Green Bank Telescope in West Virginia, and the Very Large Array in New Mexico. Their findings appear in a study published Wednesday in the astrophysical journal Letters. Searching for a celestial choir, the newly detected gravitational waves are the most powerful ever measured. They were likely caused by collisions of supermassive black holes and carry about 1 million times as much energy as the singular events detected in recent years that resulted from black hole or neutron star mergers. It's like a choir, with all these supermassive black hole pairs chiming in at different frequencies, said study co-author and NNOGrav scientist Chiara Mingarelli, assistant professor of physics at Yale University, in a statement. This is the first ever evidence for the gravitational wave background. We've opened a new window of observation on the universe. The gravitational wave background, a kind of cosmic noise that has long been theorized but never detected, is made up of ultra-low-frequency gravitational waves. As black holes collide across the universe, these waves all hum and resonate together in the background. Gravitational waves travel at the speed of light, but the astronomers realized a single rise and fall of one of the waves could take years or decades to pass by due to the spacetime ripple effect. We're using a gravitational wave detector the size of the galaxy that's made out of exotic stars, pulsars, which just blows my mind, said study co-author Dr. Scott Ransom, staff astronomer at the National Radio Astronomy Observatory, in a statement. Our earlier data told us that we were hearing something, but we didn't know what. Now we know that it's music coming from the gravitational universe. As we keep listening, we'll likely be able to pick out notes from the instruments playing in this cosmic orchestra, Ransom said. Combining these gravitational wave results with studies of galaxy structure and evolution will revolutionize our understanding of the history of our universe. Cataclysmic collisions. Scientists believe supermassive black holes are largely responsible for creating the gravitational wave background. Supermassive black holes exist at the centers of most large galaxies. But as galaxies merge, eventually their black holes begin to orbit around each other. These massive objects, containing billions of times the mass of our Sun, dance until they collide. When they do, ripples spread out from the host galaxy and eventually reach our own. It's estimated that hundreds of thousands, or perhaps millions, of pairs of supermassive black holes exist across the universe. At one point, scientists were concerned that supermassive black holes in binaries would orbit each other forever, never coming close enough together to generate a signal like this, said study co-author Dr. Luke Kelly, assistant adjunct professor of astronomy at the University of California, Berkeley, and chair of Nanograv's astrophysics group, in a statement. But now we finally have strong evidence that many of these extremely massive and close binaries do exist, Kelly said. Once the two black holes get close enough to be seen by pulsar timing arrays, nothing can stop them from merging within just a few million years. But the researchers acknowledge it's not out of the realm of possibility that there are multiple origins for the gravitational wave background, just as there are alternative explanations of how the universe began. The team will continue to study the gravitational wave background and attempt to isolate individual sources to determine their origins. The gravitational wave background is about twice as loud as what I expected, Mingarelli said. It's really at the upper end of what our models can create from just supermassive black holes. What's next is everything. This is just the beginning. Additionally, scientists using telescopes across Europe, India, China, and Australia reported similar findings, also released on Wednesday. Combining data from NNOGrav with international collaborators can provide a broader picture of the gravitational wave background, the researchers said. Our combined data will be much more powerful, said study co-author Stephen Taylor, assistant professor of physics and astronomy at Vanderbilt University, who currently chairs the NNOGrav collaboration, in a statement. We're excited to discover what secrets they will reveal about our universe.